about inference for one mean. If you recall the example we were working on, we had this initial assumption that the average length of the blue whale was probably 80 feet. We had the research question about environmental factors changing the length of the blue whale. We had some data given to us from a sample of 15 whales. We had the mean and standard deviation from that sample of 15. In the last video, we worked out a confidence interval using this data, and we found that we were 95% confident that the average length of the blue whale was between 67.8 and 82.2 feet. We asked ourselves the question, if we conducted a hypothesis test, what would our conclusion be based on that interval? Since 80 was in the interval, we said we should have little to no evidence for HA that it will be different than 80. We're going to finish this off by actually working that out to see if that is indeed the case. So our hypothesis test, our first step, we need to state our hypotheses. And we kind of wrote those down earlier. Our HO, our initial assumption is that the mean is indeed 80 feet. And our alternative, the thing we're trying to show, is that is the mean different than 80 feet due to these different environmental factors? Has it changed? Second step, we're going to collect our evidence or our data and compare that to this initial assumption of 80 feet. In other words, find our test statistics. So t-calc, not z-calc, because we're talking about means. So t-calc is going to be the mean from the data, or our 75 feet, versus the null hypothesis, that initial assumption of 80 feet. And we're going to divide by our standard error, which was our S, the standard deviation of the sample, over square root of 15. If you don't remember the formula or want to reference that, just flip back a few pages in your notes or the first video in this section. So if you work that out, you're going to get negative 1.4896. If you round that to 4 decimals. And don't be troubled by the negative. It just means our data, 75, is below the assumption of 80. Totally fine to have a negative test statistic. So we have this measure of discrepancy between my evidence and the initial assumption of 80. We're going to calculate the probability of seeing that kind of discrepancy. So here's our t-distribution. Here's my test statistic of negative 1.4896. And I'm checking out HA. It says not equal to. So I want to know what are the chances of being that far off below my assumption or above. I don't have a specific direction here. I just think it's different. So I'm going to look at both cases. Since this is a test about means, we're going to use the t-CDF. So p-value is going to be t-CDF. And again, find either side. It doesn't matter. So I'll find the upper one this time, 1.4896. Out to infinity, plug in your favorite big number. Remember, t-CDF needs a third input here to tell us exactly the shape, and that's our degrees of freedom. We had a sample of 15, so degrees of freedom is 14. That gives us this upper tail. Then remember, we need to multiply by 2 because this is two-sided. HA is not equal to, so I'm looking at both options. You should get something like 0.1585 when you work that out. All right, so we've stated our initial assumption, what we hope to show. We've measured the discrepancy of our data from that initial assumption, and we found the probability of that kind of discrepancy. Now let's put all that in plain English for our readers. So step 4, interpret the p-value. Remember, that is always in terms of HO interpreting the p-value. We plugged in the null hypothesis here. So if the null is true in this case, means if the average length is 80 feet, so if the average length is 80 feet, we would see data like ours, or more extreme. So that's our test statistic, or the parts we shaded. And then the p-value tells us what percent of the time, so 15.85% of the time. Then we need to make our conclusion based off of this. So step 5, our conclusion, we're always put that back in terms of our research question. So our research question was, has the mean length changed? Refer earlier in your notes if you need to for kind of that guideline in our wording. So this is above 10%. So if the null is true, we have a decent chance of seeing our data. So we can't rule out the null in favor of our research question. So because we have a high p-value, it's bigger than 10%, we're going to say there is little to no evidence, which is exactly what we expected earlier. For HA, and again, HA is the mean length is different than 80 feet. So there's little to no evidence. The mean is different than 80 feet. Now before you shut this off, I want you guys to write a note somewhere as a reminder about when to use the T stuff and when to use the Z stuff. So here, if the problem's about proportions, we had 1 or 2 proportion problems earlier, then you're going to use Z star and normal CDF. On the other hand, if it's about means, so 1 is what we just went over. In the next set of videos, we'll kind of do the same thing, comparing the mean of 2 groups. That's where we're going to use T star and TCDF. Okay, so if you're a highlighter type person in your notes, I would definitely highlight this as kind of a useful reminder or distinction of when you're using means use the T distribution, proportions use the normal distribution.